So just a quick introduction to polymers. Polymers, as you know, are one of the three families of materials we study, being polymers, ceramics, metals. What gives a polymer its strength? First up, it's got covalent bonds, usually. Bond strength, ionic is the strongest bond between two materials. Covalent is the second strongest, metallic is the third. So the physical atomic force holding the atoms together inside a covalently bonded polymer is stronger than the bonds holding together a metal atom. But why are they flexible and why are they weak? Because usually they're not linear. They've usually got a wavy, bent structure, like the one I'm showing you here. It is possible, however, to get all the atoms lined up. That is carbon fibre. Carbon fibre, as you know, is used in airplanes, it's used in cars, it's used where you need incredible high rigidity and high strength. Why is it strong? Because it's covalently bonded, and there you are physically on a carbon fibre pulling straight on either end of a covalent bond. It gives you an incredibly rigid, strong material. If, however, the carbon bonds are flexible and weak, you need to spend a lot of force straightening them out. Grab a bit of Glad wrap, try and pull it out. You'll notice just before it snaps, it turns white. The white is where the chains are starting to turn linear and block light coming through the Glad wrap. So, polymers are strong because of the strength of their inherent bonds. They're strong if they have a linear structure, not a random non-linear structure. They're strong when they interlock, like this one, polyvinyl chloride. This, I hope it's in the view, this electrical conduit here is polyvinyl chloride. Carbon, I've drawn these about to scale. Hydrogen and chlorine is a little bit bigger than the carbon. So what happens? If that's one chain of polyvinyl chloride, and there's another chain, the chlorine atoms hanging out the side of the chain catch each other and stop it from moving, which is why this electrical conduit is hard, as in not flexible. That's a better word than hard. The electrical conduit is not flexible because those chains lock together and stop it from moving. Of course, thermosets, as you know, I've drawn it up above. The carbon chains are linked together with a cross-linking agent, usually oxygen or sulfur. So, they cannot move because the entire block of polymer is physically fused together so the atomic chains can't move. The atomic chains can't move, high strength. If the blocks are locked together, it also gives you high strength. So that is where polymers get their strength from. They get their flexibility from the fact that the structure is not usually linear. Even carbon fibre, you can put a slight bend in the carbon chain like that and still get flexibility. Polymers are flexible because the covalent bond allows some rotation and movement. They, however, do have a high strength because of the high inherent bond strength of the covalent bonds.